Okay, so we're going to have a look at Charles' law in this video. And Charles' law is associated with volume and temperature. And what Charles actually found out was that volume and temperature are directly proportional. So if you were to increase the temperature, you would have an increase in volume, which of course makes sense when you consider those particles around and also the kinetic energy theory. And of course, we know that if you have more energy, they're obviously going to occupy a greater space. It just makes common sense. But let's have an example of this mathematically. And what we're going to do is we're going to look at a balloon. So we're going to assume that a balloon, it's quite a large balloon, has a volume of 7 litres. And it's in a location which has a temperature of 34 degrees centigrade. The temperature was then changed to 20 degrees Celsius when we actually took it inside, and we want to know what the new volume of the balloon is. And this is actually pretty cool. If you can have a very hot day in a very cold house, you might want to actually test this for yourself. But the very first thing we need to do mathematically is to convert those units in degrees Celsius into degrees Kelvin. And the reason that is because Charles' law works off Kelvin as a SI unit. So what I've got here is the G1 graphics calculator on my iPad that's going to help us out, and I'll be doing the calculations on this. It's really good. You can search for it on the App Store. It's iPad, iPhone, and iPod. I use it for all this science stuff, and what we first want to do is we want to add 273 to both those temperatures to convert from degrees Celsius to degrees Kelvin. So I'm going to go ahead and do the first one. So we have 34 plus, and then we had 273, and of course we're going to get 307. So, for the first conversion, we have 34 plus, and then we have 273, and we get 307 degrees Kelvin. Now what we need to do is we need to do the next one, and the next one is 20 degrees. So we add 20 to it. We don't necessarily need a calculator for this one because we should get 293 degrees Kelvin just by adding 20 degrees onto there. Excellent. So now what we need to do is we need to rearrange this formula. So we've got volume 1, which is the initial volume over the initial temperature, is going to be equal to the volume over temperature down there. So we know that essentially volume over temperature remains the same. It remains some constant B. If you looked at my video on Boyle's law, you'd remember that the constant K remains the same. It's the same sort of logic in this state, however it's actually in a fraction bar setup, and that's because the two quantities are directly proportional, whereas with Boyle's law we looked at inverse proportionality. So we're going to rearrange this equation because we want to find the new volume, volume 2, so we're going to bring T2 up from the denominator on the right-hand side to the numerator on the left-hand side. And we get V1 T2 on T1 equals V2. And then what we do is we substitute in our values. So we get V2, it looks a bit like a Y, so I might just redo it. But V2 equals, and we put in the initial volume, 7 litres, times, and then we have, of course, our temperature, which is going to be, in this case, because we've actually moved up from T2, this one here, 293, all on 307. And we'll do it on the G1 graphics calculator on my iPad, and what we're going to do is we're going to do 7 times 293 equals, and then what we do is we just divide it by 307. And we get a value of 6.68 when we round it to 3 significant figures. So, just by taking that balloon out from a hot day, 34 degrees Celsius, in case you don't know, is around about just under 100 degrees Fahrenheit. But when we take it into 20 degrees Celsius, we end up with a volume that's almost, well actually it's over 0.3 litres less, which is quite a lot. 300 ml is quite a drastic volume change just from moving it in. So again, if you have a balloon and a hot day outside, try this out. Key things to remember with Charles' law is you always work with degrees Kelvin, and always rearrange your equation before putting in the values, unless you like to put in the values first. That's up to you, but my personal choice is just to rearrange it, then put the values in at the last point. But really, it's a straightforward formula, and it's very interesting. Thank you for watching.